Use geometry to evaluate the double integral over r of 6 minus x dA. So use geometry. Well, I mean, you have to draw the picture if you're asked to use geometry, right? Because I know you could evaluate this with other means. So you have to show me you know how to use geometry. You have to draw the picture. So and you have to draw it in space. So let's start with the x, y, z axes. Now you have to look at r. R is given, it's kind of hard to see, but r gives you that x is between 0 and 6, and y is between 0 and 3. So let me come out 6 on the x. 1, 2, 3, 4, 5, 6. It came out one too far. There we go. And then 3 on the y. And let me think about the 6 minus x as z, right? Z is equal to 6 minus x. So what does that look like in space? What is that figure? But what is it? Is it in space? It's a plane. In the xz plane, though, it's a line, isn't it? So let's start there. And Jonas, you're exactly right. It's z-intercept. Well, if you plug in 0 for x, its z-intercept would be 6, wouldn't it? So 1, 2, 3, 4, 5, 6. So I'll plot that one. And then what would the x-intercept be if you plug in 0 for z? So that's why I came out there also, because it said x goes from 0 to 6. So, and the plane, the generating line and the plane go on forever and ever, but that's all I'm going to need to draw for this because of the given limits on x. Now, if you translate that generating line parallel to which axis? The y-axis, you end up with, at least in the first octant, a wedge sort of shape, right? How far would you translate it in the y direction, the positive y direction? 3 units. So if you translate this point up here, 3 units, so translate the whole generating curve, but it's a line, so you can just translate the 2 points. And then I'll cut it off here. And then, let's see, let me try to give it some perspective. So, okay, so z is the top part of this, right? And the reason we're getting this shape is because we're told r is given by essentially a rectangle. X goes from 0 to 6, y goes from 0 to 3, right? So it's a wedge shape, isn't it? And how could we find the volume then of this wedge? So, oh, you know what? I should be specific here. So this integral over r, geometrically, you can think of it as the volume of the wedge that I've pictured here. And so how do we find the volume of this thing? I'm thinking of it as a box, right? Half of a box. So 1/2. And then what would, if this were a box, if the top, if you put the copy of the wedge on top of it, what would the volume of the box be? It would just be, 6. I'm looking in the XY plane, 6 times 3 times another 6, but you do get 6 squared out of that as well. Do you buy that? And then, did I miss anything? No, I've got the length, the depth, and then the height is 6 also. So does everybody see where these numbers are coming from? Okay. Does everybody see where the 1/2 comes from? All right, we're good then. So what does that turn out to be? 54. And then it's good that you mentioned that. So I'll say it like this, actually. If you were given units, you would go like that, right? Units, unit, it doesn't matter. There you go.